Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about 5G, Edge, and AI with Dr. Anna Scott, Chief Edge Architect at Intel. Anna, welcome to the show.
Hey, thank you, Darren. I'm delighted to be here.
Now, Anna, you and I have been working together for, 3 years now?
Pretty close, I think. Yeah. At least 2.5 for sure.
Yeah, at least 2.5. Yeah. It's really a lot of fun because I come from the data center side. You come from the industrial side, from the manufacturing side in information systems. Tell us a little bit about your background.
Certainly. So I have been with Intel for a little over 6 years now. The last 2.5, I've had the pleasure of working with Darren in the public sector team, where I primarily support our IoT and Edge activities. And increasingly over the last year or so, I've also been getting much more involved with 5G because 5G is changing that space dramatically. AI is thrown in. That's why we decided to do the 3-tier talk today, is because those three together are what's really going to change what can be done in the application space and what kind of problems we can solve. From a background standpoint, prior to Intel, I spent 15 years of my career in oil and gas. So my undergraduate's in chemical engineering, and I grew up in Oklahoma, went to school in Kansas, which meant that I could either go to work for an oil company or I could go to work for a manufacturer that did processed foods.
Well, you could also be a farmer too. I mean, if you're living in Kansas, you could be a corn farmer, right?
That's true, but not with a chemical engineering.
Not with a chemical engineering degree. Gotcha.
So that's wrong skill set for that one. So, but yeah, definitely very much the grain belt, right? So, so I spent those 15 years. I did multiple things. Primarily, I worked as a process engineer, design engineer, and then later in my career, I did startup work worldwide, and then also did a lot of engineering management with the last job I had prior to Intel. So if you have, if you work in the industrial space, one of the things that's really true is a lot of our industrial customers say IoT was never anything new. Those companies have been doing IoT since the beginning. It was just all hardwired, and so everything was over copper, but very much very strong systems for how you pull data and then how you analyze that data to actually tell you how to run things. One of the things that's been really remarkable about being able to work at Intel is actually getting to see across multiple industries, and then moving into things like in the public sector space, where you look at what the armed forces are doing, you look at what cities are doing with smart cities, and you get to see all of this nice commonality in terms of even though there are some very refined differences of use cases and architectures who support it. The whole idea of how do you get your data, how do you analyze your data, how do you apply analytics to it, and then how do you do that in the time frame that's really significant for the business and helps make better business decisions. It's really a fascinating convergence. And so getting to go from these hardwired systems now into these wireless systems, and then having this close coupling of IT plus OT, so that you really get to converge your analytics instead of just having a set of process data that's very specific for your OT world, and then having a whole different set of systems that marry that to your business. We really do get to see that convergence of how we're pulling that all into the same space now. So it's been a fascinating thing, and having.
So I have a question around that. Nice. You said then in the manufacturing space, they've been doing OT for decades.
Oh, absolutely, yeah, and IoT,
but it's
right?
And IoT. So
yeah.
So why has it taken so long to move out of manufacturing into other areas, other industries?
It's the cost.
It's the cost.
It's the cost. Yeah. So if you have to hardwire systems, the amount of money that you have to spend to get that data, right, is huge. And then I think the other thing too is the security, right? And you've done some really good sessions with Steve Warren to really kind of talk through that. But there's still lots of work to be done on the security side to really get the conversions that I just mentioned. We're seeing it, but we're seeing it in some
pockets.
isolated pockets, right?
So,
Where
so
it's been
I have a
validated.
question around that. Do you feel that 5G is kind of unleashing the IoT world, the edge world, because of that?
Absolutely.
Oh,
Yeah.
interesting. I never thought of it that
Yeah.
way.
Yeah. I think we underplayed it, right? I mean, when we first started, when I first started with Intel and they would do the predictions and it's like this million devices, this billion number of devices are going to be in place by this time. The key to having that be cost effective is having wireless communications. And, in some industries and on the consumer side, that's pretty straightforward. And we've been doing it for a long time. When you get into the, kind of critical business, infrastructure, it's a very different conversation in terms of how to really do that and do that in a way where you're protecting your data and you've got a good sense of it. So 5G I think is absolutely going to be transformative, but we're not really seeing 5G yet. It's not really ready for the commercial sector.
Yeah. Why is that? I mean, we've been touting 5G for
for a long time,
5 years.
Yeah.
Why is it taking so long? Is it that it's hard technology or it's expensive? What do you think is the laggard here?
So a lot of it is just when they've done the standards releases and when the companies that supply the right hardware to support those standard releases are actually ready to go. So unsurprisingly, and this is what was always predicted, right, is the first place that 5G was going to show up in the marketplace was with consumer devices and with cell phones, right?
Yeah,
and
my
for sure
cell phone says it has 5G. I don't know if it really does.
um,
Probably
not as good as it's going to be, I think would be
okay, there you
be
go.
the correct way to say it, right? Because obviously there was a lot of infrastructure that had to be put in place to just to have the signal available and to support that. And then there's a whole lot of other work that has to be done to actually have the hardware to access it. Consumer markets are huge, right? And cell phone markets, obviously that just drives a massive amount of business. And then the way that they did the standard releases, a lot of the ones that like release 17, that's going to be extremely transformative for industrial and control systems, that hasn't even come out yet. That comes out in, I believe it's Q4 of this year. And then again, there's going to be a delay between when that standard is released and when companies are actually producing the hardware that's going to take advantage of that standard. So it's less, I don't think the timing is unexpected to anybody who's spent a lot of time with 3GPP or the other standards bodies that are really driving this. But just to kind of level set, where we're at right now with respect to public sector and with respect to industry is you can now stand up a 5G network. You can do that through multiple telcos or through disruptive companies. But we're at the stage of doing test beds where we are demonstrating the value of 5G, demonstrating new use cases that can't be supported by by LTE or by 4G, and that is that's really where I spend a lot of my time right now, because it's not enough to just have this amazing capability that does low latency and high bandwidth. You really need to show why you need to make a new investment into 5G and why 5G is necessary for this new capability.
What if I already have Wi-Fi 6, or if I have maybe an LTE network already, maybe I contracted with AT&T or something like that in my factory or even in my campus? Why go to 5G? I mean, I already have wireless through my whole campus. I can connect to all the smart devices I want, like I do in my home, right? I just looked on my router. I have 56 devices in my house. That's just,
so you wouldn't work for a tech company, would you? Right?
No, yeah, exactly. So what's so special about 5G? Why not just stay with like Wi-Fi 6 or 7 or whatever number they come up with next?
And it's a complicated question, right? And one is, Wi-Fi 6, a lot of the standards organizations that were driving the 5G also are driving the new standards around Wi-Fi 6. That is very much a complementary technology, and it will have a definite sweet spot relative to 5G. With Wi-Fi 6, you get a lot of the low latency and the high bandwidth. right? But then you've got this differentiator between, here's all of your equipment that you need for Wi-Fi 6, here's what you need for LTE or for 5G, right? And then it's almost, you've got to get into the details of what are your use cases, how are you going to take advantage of that, and what's the most cost-effective way? Because for sure, 5G is amazing as it is not going to be something that you're going to put into
My house.
well, it'll be in your house as a part of like carrier networks, right?
Right.
Wi-Fi 6 you could also take advantage of, but with 5G, and sorry, I'm stumbling a little bit. It's because I just had a conversation this morning with a customer who is really looking to put 5G onto cruise ships. I think we can talk about this because we won't mention the customer. But if you're in a cruise ship, your environment is not friendly to any sort of wireless signal.
Yeah.
But it's super not friendly to something like a millimeter wave 5G network because the penetration isn't there for that to make any sense. So your option is probably going to be better to do something like do Wi-Fi 6, do it with access points, at a high density that go across the area that you're trying to do coverage. So there's always these types of questions, right? But if I want to drive back to the core of your question, which is, what's really compelling around 5G and why is 5G going to do stuff that 4G or LTE can't? And, I think the answer is it's things like augmented reality, right? And virtual reality. It is, you want to have a remote expert that is standing looking at a problem that can do video and audio streaming with overlay of drawings and capabilities that are being managed back from a central location or a remote location that is really bringing all of that knowledge and expertise directly to the point at which you're trying to do the work. That type of use case can't be done over
is that
over
just
an
because
LTE network.
The bandwidth just isn't there? Is that the main?
It is.
Reason?
I think bandwidth can be part of it. I think it's the latency, especially, is what really drives
latency,
that.
Yeah.
Because for you not to get sick with a headset, you got to have really low latencies, and you can't have a delay, and you can't have things go asynchronous on that. There is also jitter, I know, comes into that, but I'm not good enough technically on that side to be able to explain that. But that is definitely something that has come up as a problem area if you're trying to do an AR case with other types of network. So that's why we're doing all these test beds, really, is to say, where can we really push into that region to show new capabilities that really can't be supported with like an LTE. It's worth mentioning, though, that there's been 5G has actually changed the LTE and 4G world as well, because of how they have managed spectrum. So one of the things that's happening that is absolutely changing what is possible from an industrial standpoint is standing up. It is now possible for a company to essentially get a priority license for CBRS spectrum, stand up their own private network, essentially control that network and everything that's on it, and do that wholly divorced from the major telcos. You can still have telcos do that, but it is huge, right? Because that was not possible before. And if you're like a large manufacturer and you've got a huge space that you're trying to cover, you can you can much more cost effectively cover that with private LTE than you can with access points. And then, just to throw it in because it's fun and kind of truly amazing, if you want to reconfigure your space and you don't want all of your workstations to be hardwired, or you say have to move around enormous pieces of metal that you're building, right, like aircraft fuselage or wings, or just kind of anything large that you're making that could actually mess up your Wi-Fi signals, being able to move into a private LTE means that you can absolutely change your entire workspace now, because you can stand up that infrastructure and now just make everything much, much more portable and not be fixed to hardwired locations absolutely everywhere, where you're doing specific workstations and things. And so that changes the world, right?
Yeah. So bandwidth, flexibility on spectrum are key. I know security is another big issue with 5G, right?
Yep.
Because it's built into the standard more so than ever before.
Not as much as everybody would like, though. If you
Oh,
talk
interesting.
to if you talk to the experts like Leland Brown, who hopefully you'll have talk to you
I
on
should
this
have Leland.
sometime.
Come on, yeah.
Yeah, what they'll say is 5G was not written with security in mind, whereas 6G will be. So that is one of the big pushes that's happening right now, is to really say whenever the work has already begun on 6G
Of
standards.
course it has.
Yeah, of course it has, and Intel's involved in that as well. That is one of the things that they are pushing, absolutely, is to say security has to be front of mind. It has to be designed in. Luckily, with the capabilities that they did design into 5G, we can do a lot around zero trust networking and some other things that will help our customers quite a bit with being confident in terms of how their data is being moved across their networks. So,
So that brings up another point. Another new technology that's kind of enabled some of this is software-defined networking, correct? Because without
correct.
software-defined networking, 5G, they kind of go hand. 5G takes advantage of SDN, right?
Right. Well, and that's a lot of what the transformation ends up being with the 5G standards, is that if you go back just a few years, right, it was proprietary hardware, proprietary software, and then you had licensed spectrum, which only a few companies could really afford to have access to, right? The 5G standards have changed all of that, and that's part of the reason we're seeing this transformation on the LTE side, is with making things like the CBRS spectrum available, and then getting away from proprietary hardware and software. Intel spends a lot of time working with disruptors that are using our FlexRAN reference architecture. And FlexRAN is our version of an Open RAN type of software, and that is one further opening up what's possible with respect to 5G and how it can be used, but also it becomes the basis for helping a lot of the disruptors that are coming into the market that are going to use our off-the-shelf servers or COTS servers, couple that with like their version of FlexRAN, and now you've just moved into this space where there's a lot more openness, a lot more portability, and it's the cost of entry is not what it used to be, and now it's no longer just a few companies controlling everything. It really is. It is very much the Wild West with respect to what can be done. Intel's not the only one that is doing that, but definitely our goal is to open everything up, take advantage of open standards, support all of those organizations that are doing that, and really support our customers and partners on the traditional and the non-traditional side to really just change the entire dynamic.
So what sorts of business models do you see opening up? Because we've kind of unleashed connectivity, right? We were saying you can connect anything, anytime, low latency, high bandwidth. What sorts of new use cases do you see that might be available? Thinking outside the box. If I'm a CIO going, all right, 5G, all right, woo, connectivity. Tell me why I care.
Yep. Yeah. So one we've already talked about, right, which is what manufacturing can do to take advantage of that, right? You can apply that past manufacturing into other places where you've got a lot of data. So there's the potential there with what you could do with smart cities and other things. So that's from like an end user perspective, right? What would that mean to them? What's happening very generally across the market is it is changing how monetization of 5G is going to be done. So it's now no longer carriers have dumb pipes that are moving all of this data, and they have their business model built on that. It becomes carriers want to monetize 5G in a way it's never been monetized before by adding services, right? And that's still being defined. And there's
like what? I mean, what do you mean by that, Anna? I'm a
uh,
little
well, so here's a way to talk about it, right? So say, because the other group that's very, very strongly involved with this are the cloud service providers. So if you
right.
say you have a cloud service provider along with a telco, and they're going to say, how can we really take advantage of high bandwidth, low latency, and what can we do from a services standpoint for our customers? is that changes everything, right? Because now those are no longer these these are no longer silos. These become a combined business effort of what really matters. So some of it can be around quality of service or priority of communications. That's a easy to understand way to monetize around 5G is monetize around quality of service and like I say, prioritization, which is now possible. But the other way to say is what you see generally as a trend is you see cloud service providers buying capabilities that are going to open up network functionality for them, the same way that you see the clouds, the telcos going in and saying, what can we really do on the cloud side? Because again, you've just broken down the silo of it's no longer a dumb data pipe and it's no longer a set of services. Now those two are really being done. And I'm
Together.
being kind of intentionally vague because honestly, we don't know how this is really all going to fall out. I think there is massive work being done on this. There's a lot of companies that have their own take on how to really do this, especially if you throw in the other things we were going to talk about, which is now you've got edge compute, now you've got artificial intelligence and analytics. It's just really redefining one, what kind of work you can do because of your data accessibility, and then where those workloads are really going to live. Because as you and I have talked about, right, we see a huge value in being able to go from edge to cloud seamlessly and doing that in a way that is based on the need of the customer, right? So that's now possible, whereas before edge was edge, right? And
Yeah.
then it made it to the cloud, and now that's all opened up.
All right, so with 5G really increasing my bandwidth and latency, we talked about a little bit about a data center without walls. What does that do to the edge and AI on the edge? Is this really unleashing that? What's really happening here?
Yeah, so we're seeing several things. So one is, with what's been happening with respect to artificial intelligence and what you can really do with how to query what's happening on a video feed, right? One of the things that 5G does is it gives us kind of two options of architectures that we can do, whereas before we kind of had one with limits, right? So if you say, I've got a camera, and in that camera, what I care about is object detection, right? 2 years ago, if we did a framework for that, what we would have to do is we would say, I'm going to close couple some compute. I'm going to have my model live next on that compute right next to my video feed, and I'm going to do streaming inference. But because of the limitations of my network, if I don't hardwire that compute back to a central location, then the data that I can actually get from that is just an alert. It's an image capture. It is something that is very minor that is going to say, hey, you've got a problem, but it's not going to be particularly rich with the data that it shares back, right? When you throw in something like 5G or what will be coming with 5G, because right now there's some limitations in terms of what you can really do from streaming video analytics or streaming over 5G. But what we can definitely do is we still need that compute and that streaming inference next. But what we have the capability to do is really share a lot more information back, right? So we can still, if we choose to limit that to just a few alerts or a few little signals, if we want to be very sparing with how we use that bandwidth. But if we want, we actually now have a capability with 5G to actually stream that video back all the way. And if we really wanted, we could actually move that inference to a remote location as well. So, and that's something that just would have not been cost effective, or you would have needed a hardwire place in that. So back to the AR example that I gave earlier, part of the reason AR is such a good starting point is now that it means you can have people on headsets that are mobile and doing all sorts of things with having the same sort of capabilities that we used to have if you were tethered, right? And as you can imagine, tethered AR is not nearly
It's
as
not very
cool as
useful, yeah.
tethered AR, and it just changes the world with respect to mobile data sources. But it also opens up some things, like I said, in terms of what you can really do with respect to how much of the video data or the audio data that you would like to share you would share backwards. And then you have this ability to do this cost optimization, which is based on what your network capabilities are and based on your criticality, where do you want your compute to live relative to your data source, right? And there are some really nice models that if you don't have a lot of tech support and you don't have a lot of detailed knowledge of how to keep systems running, if you can run all of that stuff in the cloud,
yeah.
that changes everything, right? For cases where you don't want to do that because you don't want your data on the cloud in the first place, you can essentially do a version of that that's on-prem over a private network that gives you all that type of functionality, all that ability to aggregate and collate data and do high-level understanding of what's happening in your system. But now you can do that in, again, just a cost-effective way while hitting your security and privacy
So
requirements.
it's really unleashing lots of different architectural models that can be used.
Yeah, absolutely.
And which I found it interesting when you were talking, I was thinking, well, you've really decoupled my AI and my data and the hardware. So that can reside anywhere now. It can reside on the edge. It can reside in the cloud, on-prem, in the fog, which is a Cisco term, right? Which is computing somewhere, right? Out there in the network. Wow, that I just, my mind is a little bit like, it doesn't matter where my application runs anymore.
Right. And now it can be way more cost effective, right? Because like if you think about installation, and I did a project with Intel for a refinery, and we were doing the use case that I just described, which was streaming video analytics with the inference on close coupled, right? We still had to hardwire that, even though we did take advantage of the wireless network to do the alarming and alerting that I said. The cost of that was your cameras are trivial because we can use pretty much any camera that's out there that's decent resolution. So say $1,000 for a camera. You couple that with an IPC or a gateway, which is maybe less than $1,000, right? And the biggest cost on those types of projects were analytics development, right? So developing your models, and that's getting more cost effective through all sorts of means. It's a totally different discussion. But the other was like it was the actual field installation, right? So maybe $2,000 for your equipment, but by the time you got an industrial rated box and you've done your hardwiring and you've done your conduit to get it back to a central location, that's $60,000, $70,000. Okay. So what 5G offers in the industrial space is you don't have to have that massive labor cost that goes to that hardwiring component. Because if you've got a network that stood up, now you say add another $100 for, or thereabouts, right, for the right modem connectivity. And now what you have is you still have to have local power to that site, and you still have to be able to make sure that everything runs, but you're not spending that $60,000 to install your conduit and to get your hardwire back, right? And that's huge, right?
So
and if you
all we need is self-powered, right? Wi-Fi power, isn't that called microwave ovens, something like that?
Something like that. Yeah, we're not having those discussions.
We're not having those discussions. Good. 6G includes power, by the way. No, I'm just kidding. No.
But that changes things, right? And
if you say, no, I can see that.
And you can do that with Wi-Fi, and in Wi-Fi 6 especially. But if you say, look at the number of access points that you need to get the type of coverage relative to what you could do with a cellular network, there's a huge difference there. And again, Intel doesn't do direct installations, right? But talking to some of our partners, it's like if you had an industrial, a large industrial space, say it was going to take hundreds of access points to get the type of coverage that you would need, that would have been well over $1 million. You can go in with a private LTE structure that is, order of magnitude different from that.
That's huge.
Now those wireless comms change everything, right? Because now that cost of your total solution is very different. And then again, now you can talk about where do your analytics live based on what your business needs are, which is great. And it gives you the ability to have super rich data if that ever becomes valuable, or if you know it's going to be valuable for your application and your business problem. So it's super exciting, because that in my mind is one of the things that's just absolutely missing for IoT to take off the way that everybody has predicted, is that only happens when you get the cost down so that you can really take advantage of all of these capabilities.
So how much longer is it going to be, Anna?
So
we've already been waiting 5 years for
wow,
this.
that's a hard question.
So what's your crystal ball tell you? Another 5 years, or do you see an explosion in the next 2 years, 3 years?
I think for non-control applications, the next 2 years will be really different. So things like as simple as I want to take my normal PC out onto my factory floor, and I want to be able to do everything that I can do in my office on the factory floor. That's going to happen. That's happening now, and that'll change the world for how you do manufacturing. That has other implications, but that's just the one that I've spent time with and is crystal clear. 5G is going to change what's possible with respect to controls and doing control of robots and machines over a wireless network, but that's mainly release 17, and that's something where it will be 5-year horizons, probably more realistic. And when you can do control over a wireless network and do that safely and effectively and have all of the fail safes that you need for that not to put people at risk, that will be the next level of transformation. And that's what our industrial folks are spending a lot of time with. And that is going to be truly exciting, but that is going to take so much validation and require so much stringency of review that will take much longer. Gotcha. So good stuff coming in the near future, but even more amazing stuff in the longer term horizon.
Oh, great. Hey, this has been wonderful, Anna. You've really opened my eyes on 5G. I thought, oh, it's just more bandwidth, whatever. But it's a lot more than that. It's really unleashing a lot of new architectures, a lot of new use cases. And as you said, disruptors are out there creating new business models around this. I think it's a wonderful time.
Yeah, it's like pay attention to your favorite cloud service provider and your favorite telco and see what they are going to do together to just change what's possible from a services standpoint, because that's going to be really exciting to see over the next year or so.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and do something wonderful.